So okay, let's move to the how to build up embedded system and IoT systems. So based on Snap, and because when you write an embedded system, there are a lot of API you need to learn. So how are we going to simplify that so that you don't have to memorize all these API, and they will give you some hints so that you don't just, oh, there's some hint here, so you can drag and drop these API into the programs. And this is our lab, our center, so iot.ttu.edu.tw, and we have a tool called Snap4IoT. Basically, we have more tools actually. This is tool for ESP8266. We have tool for ESP32, which are not on the public side, and we also have tool for machine learning. Okay, so these tool can compile your program into Lua, because as I mentioned, ESP32 they have a Lua virtual machine, so you can compile to the Lua code like this one. Then we can build our own embedded system or IoT applications. And we can also compile to Python, as I mentioned, machine learning based on maybe R language and Python language. So, and maybe Java. So, but Python is more popular, when we, working on deep learning. So we can also compile to Python, C, and C++. So our tool have the original 8 categories, but we also add another 8 here. And let's see, the sensor mean, you want to read something from the outside world to the processor, then you go to this category. And you want to control something, based on the sensing information, then you want to make some kinds of action, then you go to the actuator. So sensor and actuator are very important in embedded system designs. And then when you try to go to internet, or like Internet of Things, then you need some networking API, and you need to know the coax protocol, you need to know the MQTT protocol. And protocol here means you might want to use UR, you might want to use I2C, you might to use SPI. Do you know these terms? SPI, yes. I2C. When you are in MEN, you actually teach some these standard, or do you ever use SPI?
We have a project in 3rd year, and some of us have to work on the EDC purpose or SPI.
Oh, okay, great. How about I2C as well?
No.
No, but this guy do, but you don't?
No, I don't.
How about SPI? SPI, do you understand what's SPI? It's some kind of protocol, For example, SPI was used like ESP8266 CPU. They try to have some kinds of peripheral called 4 mega flash. And SPI are full duplex, so you can read and write at the same time. But maybe we can, have some, introduction for this very important peripheral API. So we can just use simple GPIO. Maybe you can write high and write low to the actuator, or maybe you just read 1 or read 0. You want to read something from the world with the digital I/O. But actually, more than that is you can use I2C or SPI or UR to do more complicated stuff. Okay, so this protocol actually will be more advanced. If your CPU want to communicate with some other devices, which can be read and write, and you will use more advanced protocol. And NodeMCU have some functionality for basic stuff. Whatever you want to build embedded system, or you want to build the IoT, you need some API from the NodeMCU. And CoAP is IoT standard, MQTT also an IoT standard. Rumo is how are we going to control and Rumo robot. Rumo robot was designed in Italy, and we would try to get into this data. So this is first tool, and the second tool is called ESP Plotter. ESP Plotter is kind of an IDE, so you can write program here, and then you use either send to ESP or save to ESP. So this part is your, in your PC or desktop, and the the embedded system part, or maybe the ESP8260, 8266, 826. Okay, so the NodeMCU will respond in this area. Okay, so you need to, like, for example, first you have to connect your PC or notebook to the NodeMCU first, right? And then you have to write your program, and then you have to maybe download or upload your program to NodeMCU, and then the execution result will be shown here. So this is the Explorer, ESP Plotter for NodeMCU. And the tool can be found in a tool, and this one and the last one here. So this one is web-based, written in JavaScript, so it's a web-based. So there is no need to install anything at all. But Snap itself actually suggests us to use Chrome instead of IE or Firefox, because they, these different browsers have different kinds of, behavior when you write your JavaScripts. So he suggests, you use the Chrome. And this one is written in Java by a Russian guy, and you have to, have Java runtimes to run it. Okay, so I guess you guys already installed this. So let's see how to use this tool first. So if you double click the ESP Plotter.java, then you can make this application up and running like this one, right? Your guy is running already, right? Yes. And then if you want to write program, and you can say why, and then type control. Then you can have code inside, code assist or code inside. So for example, we have a file.
You're low on battery.
Really? Okay. Let's maybe. And then you say control space, and then all the possible way they can show us for is called code insist. This is the one thing you might want to do. Okay, so maybe I need to just stop a little bit. So how do I connect to the NodeMCU? First, you plug. Maybe I just use this one. First, you have to use an micro USB 9 here. Say for example this one, and then connect to your your devices. This is the IoT Rumo board, right? And then you go to, let's go back to here. Then you do something like refresh. And you have to set the baud rate to 115200, and then say open. And if it is open, then sorry, should be COVID here. So so if you see a greater sign here, then it's connected already, right? Okay, so this is the first step. You prepare, you connect to the NodeMCU. So remember, this part have to be 115200, and this is refresh button. Click the refresh button and choose your COM port, which connect to your IoT board, and then click open. And then you see a gray sign here, and everything should be fine. And after you do it, and you can have a reload button here. They will preload some programs designed by us. So these files actually store in the flash. So if we go here, and we have a reload button here, right? We just say reload, and then you can see that a bunch of files actually happen here. And we have some. Then we can write our own programs to write program and then put it here and then download to the NodeMCU. And they also provide some testing program. For example, they provide some co-app programs, but we need an IoT gateway, so we are not going to try for at the moment. We will wait until we talk about what's the co-app. So okay, we are ready to design our own programs. So let's go to how we are going to write programs. So there are 5 steps we have to use. First step is create an NodeMCU projects. So you go to the NodeMCU and then new NodeMCU projects. And if you do, you click the you select the new NodeMCU project, and what you got is you have a compilational block called run block. Okay, so maybe you want to try to do it. And so, for example, I click this one, and I select the new NodeMCU projects. And as you can see that some programming block will be hiding. So for example, a motion block, there's nothing you can use to compile, right? But they do leave some like control block, like if else, for loop, and a while loop, which you can use in Lua programming language. So some block actually will be hiding if you select this NodeMCU project. Okay, so maybe we should go to the NodeMCU first because we want to write our own programs. So let's see the next step. The next step is you write codes. How do you write codes? You just drag and drop the blocks into the compilational run block, and everything should be fine, right? So that, and then the third thing is you save file. You can save or save as. Okay, so let's try to do it. So let's try to first. Maybe we want to read the temperature information. Do you remember which pin we will be using for reading temperature? It's 7. Okay, maybe we can check it out. It's 7. So we go to the sensor, and actually we already have an API ready for you. So you read from pin 7, and when you read, they will store in. If everything is fine, they will put in the status. And if you don't want to this one, you just put it here, and then they will delete it. And the temperature and humidity. Okay. So the second thing is we go back to the NodeMCU, and then you maybe want to try to print out something because you reading, but we don't see it, right? So you want to print. So remember, see, we have some triangle size here. It means increase or decrease. So we increase one more parameter by just clicking this one, and we need 4. We say temperature equal, and then drag and drop temperature variable here, and humidity equal, then drag and drop humidity here, right? And then we have a programs, but this only executes only once, right? So usually in embedded system we actually need a timer. The timer mean, say if you are not able to, cover these two, you can just put it here and then draw the whole thing into inside, and then you let the block go. Okay, so let's see. We use a timer, and you can decide how the frequency of the timer. So here every minute we will ask you these programs. It's similar like a while loop, while true, but you do something late. Okay, but instead of blocking the CPU running, it is non-blocking. It's called interrupt, right? So if you use delay, actually it's busy waiting. Say suppose you have a for loop and you say delay something, and then it's busy waiting. But this is some kinds of interrupt. So when 1 minute happens, 1 second happens, they would call this function. Okay. So this is the writing program as we mentioned here. The third step is we compile this programming block into Lua programs. So we put inside the run block, and then click the run block, and as you can see that the code block in the stage, they will show you the compilation result. Okay, maybe wait a little bit.
Just no time to catch.
You will catch. Maybe just you click a run block, and then they will compile this block into a Lua program for you, and they will show on the stage in the code block. Okay, so the Lua program already generated. So the next step is here we right click this one, and then choose export to Lua file. So if I say there is no program here, right? And suppose we say actually we save it because the NodeMCU is the default file name, right? So we go to this one, file menu, and maybe want to save as another file. So maybe we say DHT7 with pin 7, and then save it. So the name will be DHT7, okay? And then we click this one, and then we export Lua file. And as you can see, they will write a program to your download directory, and at the same time, they would send this file to ESP plotter and something like this. It's okay.
I have some problems reading my code.
The last step is you need to download the NodeMCU to run the application So how are you going to do it? So they have some execution button at the end of the ESP plotter. One is called save to ESP, the other is send to ESP. So suppose you have program here, and these will have some green button to show it. If there is no program, then this button will not show. So that right now if you have program, then you can enable these two buttons. So what difference between the send to ESP and save to ESP is when you use send to ESP, they send your Lua program to from PC or notebook to the NodeMCU. The second thing is they will run the code. However, they do not save the code in Flash. When you say save to ESP, they send code, upload the code to NodeMCU and run the code, and at the same time they also save the code. So let's see. In most of the time we will use just send to ESP because we just want to try out. So when you would like to save to ESP, you make sure that you might do some releasing to your customer. Then you save to here. Say let's try both. Let's see if I send to ESP, and then you can see that right now the temperature in this room is 25.8 and the humidity is 49.3. If my hot air through this temperature, and you can see that the temperature, the humidity, rising, right? And if I do more times, and you can see that it will dramatically, go to the maybe 99 something, and and if you do something like this, you can, cool it down a little bit. So you do something like this, and you can cool it down a little bit.
So again, I've got 30 degrees.
30 degrees?
Yeah, but it's because
it's impossible.
No, it's because it's behind my fans.
I see.
So my computer,
heated. So if we put something like this one,
it should go down.
Go down a little bit. Okay.
Getting there a bit slow.
So everything is work fine. Yeah. Okay, great. So let's see. So you can read all this again, and there is no like a DHT7 here, right? However, if we set to if we want to reset it, we just put some kind of reset here. So this is called soft reset. Reset by program means soft reset, and we can also have hard reset. Hard reset is we press this reset button. So if we press this reset button, then it's called hard reset. So let's see, if we save to ESP, and the same, they will try to upload it and then execute it. And if you put the hot air, then the temperature and the humidity will go high again. And then you reload this one, and then you can see that DHT7 actually is stored in the flash. So what does that mean is next time you don't need to upload the programs, and the only thing you need to do is you just click this button, and then you can run it, since the program already reside in NodeMCU. So you just click this button, and then they can run it again. And not just click this button, you can use program to choose which program to run instead of click the button. So what does that mean is unlike Arduino, there's only single file, single program you can run. In the NodeMCU, you can store a bunch of programs here and use program to decide which program you want to invoke, something like that. So I guess this more flexible. Consider you have bunch of application you can store in the flash and choose a file to run, which is much better than Arduino. The second thing is Arduino is only 8 bits, which is almost impossible to do some encryption and decryption to protect your data. However, a 32-bit processor have the power for encryption and decryption, so that this chip is more fit for IoT, and Arduino is more good for maker. If you want to do something fun, that's very fine. But you want to do some industries application, then Arduino might not be fit for that kinds of application. So is everything fine right now?
Yes, of course.
Great. So let's try to do some hello world in embedded system. When we say hello world, actually we like to bring in the LED. Since you do not have any what should I say, no displays, right? So the only thing you might have is maybe LED. So LED can show you the some status. For example, on and off, and faster, fast blinking, slow blinking, could be 4 different states, something like that. So let's try the blinking. So instead of doing this for you, I think maybe I just show you how to do it, and then you can try. So as we mentioned, there are 2 LED, right? D4 and D0. Okay. So in this case, we actually use D0. You might try to D4 as well. That would be no problem. So first, you set the pin as input and output. So I guess I should mention that the better way for writing this program is you in the beginning, if it is sensor, you set, just do it once, right? Set pin 7 as input. because you don't know that the pin 7 is input or output when you got the board, right? So the better way to it is actually set pin 7 to inputs. So the same here. If you want to say pin 0, it could be set into input, could be sent into output. So you need to have set pin 0 to an output pin. And the second thing is you create a variable. How do you create a variable? So you go to the NodeMCU and go up here, and they have set some variable, right? You just click this one, and then you can set some LED status or whatever, LED state. So LED state is 0 or 1. So in this way you set variable, and then you put inside here and click, and then it just some 0 value put into the LED state, something like that. Okay. So and then go back to the slides, and then you drag and drop a timer. And we have actually 7 timer you can use, and which timer this is the zeros timer. So they are 0 to 6, so you can choose any timer you like. And then you use a block called if else, right? So if the current the LED is 0, then you turn the pin to high. Actually, the logic here is LED is 0, you turn the LED on, and you set that LED is 1. Otherwise, you set the LED to 0, and you set the pin to low. But in our NodeMCU, the LED is active low. Do you know this name?
Yes.
Active low. So that means if you have a low value, then it will turn on. Okay. So in this case, I guess here you have to say GPIO.low instead of high. So you can choose by click this button here. So maybe the better way is I just do it once, so maybe you will not have some confuse. So for example, I maybe try to review a bit, or do the whole thing again. So in the beginning, you create a project first. After you have project, then you decide, do you want to read some sensor, or do you want to control the outside world? You want to use actuator. In this case, actually, we go to actuator, right? The reading temperature is sensor, but here is actuator. So we drag the first one, and we suppose we use the pin 4, and then they set output already. That will be great. Okay. And then we need to know, here we have a digital write pin 4 to high, and write digital 4 pin 4 to low. So we can do something like that. So we probably save these 2 buttons, okay, and these 2 blocks. So that we go back to the NodeMCU, and then we remember we still need a timer, right? So we have a timer here, and then we have timer, and we need to set the initial state. So we have to have a variable. So set maybe just pin 4, right? Set pin 4 to 0, okay. And then you drag and drop an if else. So go to the control, and then drag and drop if else here. So go to operator, and then drag and drop and test equal. Okay. So is pin 4 is equal to 0. Mean right now there is nothing is turned on, and because it's active low, right? So I write low here. And then you want to duplicate this one, you can just right click and copy this on block. So you do something like this. So if pin is 0 and you make it 1, right, and set low. And again, you can copy these 2 blocks. And then if otherwise, it will set to 0, and the pin was set to high. Okay. And then you put it back. And then save it. as blinking LED. Okay. And then click the Run button to generate the Lua code, and click the code block and export the Lua file. And Lua file will be here, right? And then you send to. Usually you want to reset it. You don't want to run two programs at the same times. And then you send to ESP, and you can see that it's blinking. So suppose I change this to 0.1 seconds, do the thing again, so that I guess you can see that the blinking will be as fast as possible, so that we can just change here and then send to ESP. And you can see that the blinking is 0.1 second instead of 1 second.